Hi, welcome back to Coding with Doc. Now on this one we're going to be going through coding at the most advanced level that I'm intending to cover. And in reality we're going to work through a series of 5 different books. This is the first of the lessons, beginning on what I would call book 1, but really fundamentally we're looking at the difference between procedural and functional coding. Yeah, and in kind of practical terms, that's moving on to using definitions, which you might have used at GCSE. So, welcome to my advanced session of Coding with Doc. Now, the aim of this is going to be split up over various topics, and this first topic is going to look very specifically at the idea of functions and procedures and breaking your code into functions and procedures. So at GCSE, clearly it's possible to kind of broadly ignore functions and procedures, where you've kind of avoided writing programming in chunks or in sections. You just write it as one big block. A bit like, say, a wood carver might carve a whole thing, a whole statue out of a piece of wood, as opposed to, say, somebody with Lego pieces might build it up. And really, the logic of functional programming is that you can build certain sections and put them together, and then you could reuse those sections on other programs. And it makes the program much easier to read as a result, and it means that the program is probably going to use less memory and that we can reuse that code. Now, you'll notice as well that on those earlier sessions, I was using a package called Trinket. And what Trinket does is Trinket allows you to program on the screen. Clearly, at this level, you're going to need slightly more tools than you'd get ordinarily in Trinket. And so I'm going to try and avoid Trinket for that particular reason and just go straight into Python. Now, if you put idle in on a PC, you'll find various versions of Python, and pretty much any of them will do this. When you first go in, you get this screen. You go to File, you go to New, it'll give you a programming window, and all I've done is arranged it so the programming window's on the left-hand side and the run window's on the right. Every program we write needs to go on this side, in the left-hand side in the programming window, not on the one with the arrows, which is the run window. So don't get the two muddled up. Now then, in terms of code, if I do a straightforward print hello world, when we were doing these kind of basic PRIMM methodologies, you know fine well what that's going to do. So when I press run to that, of course, it's going to want to save it the first time round, but it's only going to do that the first time round. And I'm just going to throw it onto my desktop as the single word example. So I've just thrown it on there on desktop, and it puts obviously print hello world, puts hello world on the screen. Now then, if I want to change that, so instead of saying print hello world, I go definition, first procedure, bracket, bracket, colon, and then I go print hello world, and I leave it at that, and I run it. What do you think's now going to happen? Well, that's what happens. Nothing, because the procedure's not been run. All I've done is made a kind of a Lego brick using an analogy I was using earlier on. All I've done is made this particular brick or section of code. I haven't activated it. So if I wanted to activate it, I'd just go first procedure, and that would run it. Now, in your GCSE studies, we tended to structure these with kind of a start section that would maybe have the variables in, and then a section that would have the definitions, and this would be a definition, and then the main program. And so here you can see the main program is running that first procedure. Those hashtags clearly do nothing in terms of the program. It's the first procedure bit that runs it. Now, if I wanted to run that 10 times, I could very easily just do this sort of thing. So I could do 4x in range 10. and then I'd put that in that loop, and then I'd run it again, and it'll call that loop 10 times. So it'll run that program 10 times. So all those are giving you this kind of chance to kind of look at code, predict what code's doing, think about how code's working, etc. Now, you can use it in a host of different ways. So if we're taking this same sort of basic structure and the same sort of basic example, let me play with that a little bit. So if I do a definition which we'll call old friend, and then we'll do a separate definition which we'll call new friend. And then in the old friend, I'm going to put a print that says print. It is lovely to see you again. It's an old friend, somebody greeting again. And if it's a new friend, I'm going to go print. It is nice to get to know you. So we've got two kind of basic print statements. Now, if I wanted to activate those in the program code, I could do something that says question 1 is an input that says, have we met before? Yes/no. So we've got a very simple, have we met before, yes or no. And then in answer to that, we've gone, if question 1 equals a yes. I haven't bothered to kind of capitalize it or do anything around that. So if it's an old friend, we're going to run old friend. And then we're simply going to do an else, otherwise run new friend. And so you can call these bits of code in a piece of broader code and have it work. So if I run that again, you'll see the same thing, and you'll see it's just hoiked me up there quite reasonably, because the question should be, is it the same as y? So equals. And then I run that, and it says, have we met before? And I put yes. It says, it's lovely to see you again. It runs the old friend routine. But if I put no, it says, it's nice to get to know you. It runs the new friend routine. So this is giving you a chance to look at this idea of predicting, to working out what's going on. Now, if I'm wanting to look at that and look at the order, if I did a definition that I put go, and in that I'm going to very simply put inside my definition of go, print the word go. And then I do a second definition and I put the word steady in, and we put a print in there that says steady. And then last of all, we put a definition that says ready. And we put a print in that obviously says ready. Now, when it comes to running those, the question is, does the order that we've coded them in affect the order we can call them in? So can I go ready first when above its last, and then steady second when above its second, and then last of all go third when go is first? Now, sorry, I just noticed I've missed that missing bracket there. Now, if I run that, will that run? Now, this is giving you a chance again to do one of these predict examples where you're just looking at the code and saying what will happen. So if I say run that now and I press OK, you'll see that that does work. It'll go ready, steady, go. So the order you put your definitions in doesn't matter at all in terms of that structure and that order and that pattern. Now, what I would like you to think about at this point is, can you change this so that it does a set of programs that in effect works like an auctioneer's would do, where it'll say going once, going twice, sold. Yeah. So can you alter the code that's there on the screen to do that kind of investigate example and that run example of your own and see if you can get that to work? So in terms of that investigate example, I'm wanting to alter this so it works like the auctioneer would do. And so I might change this one to saying going once. I might change this one to saying going twice. And I might change this one to saying sold. Now, if I did that, it would stand to common sense to probably change the names of the definitions as well. I don't need to, there's no reason to do, but it just allows us to know what we're calling. It's got a sensible name. And I'm going to pick up that idea of sensible names again before we go on to our next set of kind of predict examples and just push it further. But you'll see if I run that now and I put in once and then I put in twice and then I put in sold and I run that, it's going to say going once, going twice, sold. And so I press OK, going once, going twice, sold. Let's turn to a make challenge. So I want to wrap up this first little segment of this first lesson on the advanced with just testing how much you've understood what we've just done around subroutines. So I want you to use the basis as being that old friend, new friend task that we did before. I want you to create 3 subroutines. One called admin access, one called guest access, and one called standard access. I want the user to be asked to type in a username, and depending on what they put in as username, I want it calling one of those different routines. So if they put the username as admin, it should call admin access and put a message that kind of identifies them as an admin user. If they call standard access or just type in a name like Andrew or James, then it should return a standard access comment that says hello to that person's name. And if they put in guest, it should just return a hello to the guest. Now, I'll give you a chance to do that. I'll then go through it, and then we'll go into another kind of cycle of some predicts, some runs, some investigates. But I want to take us on this next one from looking at procedures to looking at functions. Well, this was the task, and what I'd asked you to do was to focus on that idea of the old friend, new friend task, which was the kind of the if statement we'd made with the various definitions built around it. So let's look at how we can resolve this task. In my programming window then, I'm going to do a definition that says admin. And then I'm going to do a separate definition that says a standard, and a third definition that says a guest. So I've got 3 definitions. I've put nothing in them at the moment. Just for the sake of completeness, I'm going to have my main program there, and I'm just going to put a little hashtag at the top that talks about my definitions, and the same if I do imports in a little bit and variables in a little bit. Any of those you can put at the top in these sections. It's just good practice to have your program well structured in that particular way. So in my main program, I want to go username equals input. What is your username? So you've got that basic idea, and then if username is the same as admin. Now you might want to do one here that does username equals user name dot lower, that just moves everything down to lowercase so that it copes with admin in capitals or admin with a capital A, what we call camel case or whatever. But if that happens, we clearly just want to run admin. Elif username is equal to guest. Then we want it to run guest. But because the final one, it could be Andrew, or it could be standard, or it could be lots of other things, that goes down as an else condition that will run under any of them as an else. And here you can do a print that says, welcome, you have administrative privileges. Here you can do print, welcome to the system. Now obviously normally your definitions will be much longer than these, but I've just done a kind of a basic working start definition that kind of gets us up and running, and print, you are a guest on the system. So all those give us the kind of the basic working start of that, and when I come to run it, it sits there, it wants me to save it again for the first time, so we'll just throw it onto my desktop again, and we'll put it down just as an example. Yeah, we'll replace it. And it's thrown up there my single equals. See how often I've missed that. And when we run it, it says, what's your username? And if I put in admin in capitals, it goes, you have administrative privileges, because it swapped it to lowercase and then recognized it as being admin. If I run it and I put in James, it says, welcome to the system. It recognizes me as a basic standard user. And if I run it and I put in guest, you notice I've done it in camel case just to test that again. And we run, we run it with guest, it says you're a guest on the system. So that gives us an answer to that particular section of the challenge, and that's the end of that one. Now, what I want to do at this point is to move on to look at some broader ideas around how we are using these tools of a procedure and also of a function. Now, up here I've called it a definition. A definition is a kind of a wider term for both a procedure and a function. So in terms of the exam might ask you what is a function, or it tells you something's a function and it leaves you the last line blank. The difference between a procedure and a function is a function always returns a value back to the main program. So in effect, it runs that subprogram and then returns something back. Now here, where this program's running here, you can see it's running. If it's admin, run admin. And this bit about welcome to admin privileges is happening inside admin as it's run admin, and then it stopped running admin and moved on to the next bit. So there's nothing going back into the main program. So now I want to show you this idea of being able to return something into the main program. So if I write so we're kind of looking at this and looking at kind of predicting stuff and how things might be being worked out, etc. Yeah, and then I'll take it and we'll do some sort of basic number conversions in a minute or two. But let's if I say want to do a conversion between, say, miles and kilometers, I might create a definition called miles to kilometers. And inside miles to kilometers, I could say print welcome to the distance calculator. And then I could say input or miles equals input. How far did you travel in miles? And then having done how far did you travel in miles, I could then do print miles times by, I think it's 1.6 miles in a kilometre. And then down here in my main program, I might do a print that says, again, welcome to the distance calculator, although it's going to now say that twice, so that seems a bit of an overkill, but you'll see where I'm going in a minute. And then we just run miles to kilometres. Now you see that's running in one way. That's running in the way we've just done it, where it's made a definition, does everything in the definition, and then prints out the answer. So if I run that, how far did I travel in miles? I put in 30. Miles times kilometers, my input here needed to be either an integer input or a float input. So I'll change that to a float, just to tell it it's a number, of course. And then I run that. It says how far did I travel in miles? I put in 30 and it says that's 48 kilometers. Yeah, and if we wanted the kilometers to appear, you could put comma km. Yeah, just to tidy it up and make it look that little bit neater. So again, we'll try the same one, 48 kilometers. Yeah. Now, that's running as a straightforward procedure. It runs it here, nothing goes in, nothing goes out, it does all the work up here. So if I wanted to tweak that, let's just take that second print statement, that first print statement out, because, or the second one as it appears on the screen, because we don't really want it. And I want to now run miles to kilometers, but I want to store a value. So we'll say distance equals miles to kilometers. And in here it says do this, and then in fact, let me just keep that original statement there. We'll put that into the main program. And now what we change this to is return miles. So now what's happening is it's going, welcome to the distance calculator. Store whatever comes out of miles to kilometers as a variable called distance. And then when you print it, print whatever came out, distance, times by 1.6 becomes kilometers. And here, inside the definition, fundamentally, we're just asking a question. So now when I run that, if you predict, you'll see that what that does, ostensibly, is exactly the same as the previous one. But logically as a program, it's working completely differently. This time round, it's asking the question in the definition, but then it's making all the processing occur in the program. Now, you can tweak it further. So you could do this. So you could, in the main one, do miles is a float input. How far is it in miles? Distance is miles to kilometers using miles. Expect miles to arrive in the program. And then in the program, we create conversion. You can have it the same variable name, or you can have a different variable name. So I've used miles already, and I've used distance already. So I was just making up a third one. Conversion is miles times by 1.6. And then having done miles times 1.6, we're saying here it's running miles to kilometers based on miles, brings back distance, it's returning conversion, conversion's then been stored as distance. Distance now doesn't need timesing, it just needs printing, distance kilometers. So now we've done, so the first time round, all the work appeared in the program. The second time round, the program returned an answer and it was printed in the main program. And this time round, we've got it so something goes into the subprogram and something comes out of the subprogram, and the conversion just happens in the subprogram. And if we run it, sorry, press the wrong run. It's F5 to run. It's a quick way to run it. How far did we go? 30. distance 4.8. Now, if you looked at those three in terms of the output, they're identical. But if you look at those three in terms of the way the program works, so that's shown you how to do functions and both send data into a function and pull data out of a function and decide where you want the processing to occur. Is the processing occurring actually in the program itself, or is it something that the function's working something out, or is it something that the function's just returning a value for, etc., etc. Now, I want to show you how that works in different ways. So if we follow that same structure as before, we put imports here, and then we're not going to do any variables, so we'll put our definitions next, and then we'll have our main program. Now, if I then go up to my imports and I ask it to import random, so it brings in a random number, and then inside random number, I go down and I ask it to make a random number. So I say dice1, don't put space in obviously, dice1 is a random dot randint between 1 and 6. And here I choose to print dice1. It's going to print out the number that's rolled. So when I run it, obviously it wants me to save it again, so I'm just going to go to desktop and I'm going to keep it as that example. And it gives me 6. Now, what's interesting here is if I put that into a loop and say, so I do it for x in range 10, so it's going around that loop 10 times, and ask it to print the dice, will it give me 10 different rolls of the dice, or will it give me the same roll of the dice 10 times? So you see, that's a very different thing it's doing. So there, you can see it's giving me the same roll of the dice 10 times. So now, if we restructure that and we make a definition which we'll call rolling, and in my definition which we'll call rolling, I will go take the act of the roll, that dice1 is a random number between 1 and 6, and then here I put dice equals rolling, so it's printing, let's call it dice1 because it's dice1 there, and up here we'll call it die. You can call it the same thing, you could call it dice, there's no advantage. But dice1 is going to print each time, and then rolling is going to be the action here, 1 to 6, and what we want this to do is to return the value of die at the end of it. Now if I run that, it does exactly the same. It's kept the same number, but it's activated it each time. Here, it's rolled it once, it's come up with this random number, saved it as dice1, and it's printed it out that set of times. Whereas if I asked it to print, and instead of doing dice1 there, I said print rolling, and now I run that, you'll notice it rolls the dice every time it goes around that loop. It's, in effect, it's using the function as a kind of a new roll of the dice each time round, each time as it goes through. So that shows you, again, taking a return out, but feeding numbers in and seeing how those numbers work differently based on the fact of each time they're going in. Now, I want to take the same idea, but this time instead of doing something with numbers, do something with words. So in order to do something with words, I'm going to take out the imports at the top. I'm going to keep that kind of definitions idea. And what I'm going to do here is put in greeting, and carried into greeting, I'm going to carry in first name and surname. So I'm carrying those two things into greeting. And inside greeting, what I'm then going to do is return first name And then after that, I'm going to put a space in the middle, and I'm going to then add in surname. So all it's going to do is join first name and surname. So now down here in the main program, I'm going to do a print, welcome to the system. And then having done that, I'm going to ask it to say, name one is an input that says, what is your first name? And then name two is an input that says, what is your surname? And then we'll put joined is a run of greeting, but taking into greeting name one and name two. And then in the program itself, you could do print hello, and you can then put into hello joined, and then you can say it is lovely to meet you. So if I ran that, what you'll see now is that there's words being joined in the definition. The main program is taking those, feeding those two names into the definition. Well, it's a function rather than a definition, or a function as a type of definition. And then it's joining them, it's returning back to the main program is accepting the joined, and then somewhere else in the main program, it's using them joined together. And if I ran that and it said, what's your name? And I put in Ben, what's your surname? And I put in Stokes, and it goes, hello, Ben Stokes, it's lovely to meet you. And you can see how it's joined that together, it's taken that together as a single thing itself. Now, that covers the kind of the basics of being able to join things. So what I'm wanting to do now is a basic run through of a kind of set up to a banner, and then look at kind of how the machine can be used to handle numbers in definitions before we get onto some kind of examples and some questions. So if I create a definition which we'll call fancy, and I'm going to do some nice tidy banner, and into this we're going to bring in a message. I haven't decided where that message is going to come from yet, but we'll do a basic menu system that does all this. And then we'll have a temporary message which will just literally leave us a blank string to begin with, and we'll create a kind of a character in the middle. So we'll say character, in fact character's not, call it character. I have a feeling that character might be a command, or it might recognize character, so we won't use character. And we'll say for letter in a message, because message has been brought into this particular thing. What we want to do is we want to make that temporary file that we've just made at the top there, yeah, we want to make that to be a so there's a letter coming in. We want to make that equal to the character plus the letter. So in effect, it's going to go star and then the first letter, star and the second letter, star and the third letter, etc. And then at the end, we simply want to return that temporary string. So that gives me a kind of a way of doing that kind of fancy message. And now if I do a definition which we'll call menu, and I don't think I'm going to need anything particularly on menu. We might do later, we'll see. But what I want to do to start with is print. Now print fancy, so the message that we've just used, and we can put into it any message we like. Now I could do an input that does it, but I'm just going to call it something like the ordering system. I'm going to do something with numbers in a minute on ordering. So what I've told it to do is take in ordering system and print using fancy that. And then I can do a print which is just blank, and then I can do a further print where I say option 1, put a set of numbers in order, and then we could have a option equals an int input, so it's a number input. What option do you wish? Now, clearly, the system I've built there isn't great. There's nothing to stop them crashing it by putting in a non-number, and there's only one option. But if I was to do that, and then in the main program tell it to run the menu as part of the main program, and I run that piece of code, you'll see that it's complaining that I didn't put that second bracket in. You'll see that when it runs now, it does a kind of a fancy printout of the actual system itself. So it's lapped round 4-letter in message, send round that, and we've only got a single letter there. Temporary equals character plus letter. It's gone to the last M of ordering system. So temporary equals temporary. There's a logic error there in what I've done. Temporary equals temporary. Keep the old temporary and then add the character in the message. And now if I run that, you'll see it does ordering system, looking pretty, and then asks what option do I want, and I pick number 1, and it lets me through, and we've got that kind of basic menu system sorted out. Now, what I'm wanting to do then is to turn to look at a set of numbers and how we can train the system to handle a set of numbers, to rank them, to put them into order, to work through them, etc. So, in order to do this, I'm going to need a list of numbers to begin with. So I'm going to go up here and I'm going to put in a hashtag, and by all means follow me along, create this text along with me, create something called variables. Let's call it list, so it's a list of numbers, and I'm going to put in a random set of numbers: 1, 2, 4, 6, 8, 9, 3, 4. So we've got this list of numbers that's a global variable. It's going to go through the whole program. Now, if I want, we could build these into the menu, but I've shown you how to do a menu, and you could extend that yourself if you wanted to. So if I want to do a definition of average, and what I want to do with average is bring in a number that's in list. So we're bringing in numbers that are in the list. And what I want to do then inside that is to simply return a float of the sum of in the list divided by the length of in the list. Now you can see I've used underscores for in list because it'll want those underscores there, and then I need a bracket to wrap round all that. That's just going to return that as part of average. And then if down here I want to do a print, that I say I want to print average, and I want to print an average of the list. So I called it in list there, but it's just list that's going in. Now, if I then run that particular command, you will see what do I want? 1. But then it gives me 4.65 is the average for that list. Well, what it's done is it's picked up every number in that list and it's ran that against it and managed to work out the whole lot as one piece. Now, I want to then take that same idea and look at how that can be used to then rank. So if I do a definition which we call now ranking, and we take in the list, and we take in another value, and we'll call that item, list and item. So in here, once we're in list and item, we'll start with a position. So we'll go position equals 1. And now 4x in the list. If x is greater than the item, position plus equals 1. And now what we then want to do is return the position. Now, if I take that, and now in my main program I go print using ranking, I want to print my list, which we called at the top list, and I want to take in a position. We'll start with position 2. Yeah. If I now run that, what you see is it gives me the number 7. Now it gives me the number 7 because it's looking at the list and it's saying how many numbers are greater than the number 2. Now it includes the 2, so it goes 2, 4, 6, 8, 9, 3 and 4 are all greater. Whereas if I were to move that number to say a 4 and run it again, it's looking at the list and saying how many are bigger than a 4, and this time round it's saying there are 4 bigger than a 4. Or if I were to run it based on a number 9, let's also just take out that menu command and take out that print command. Run it based on that 9. You'll see that it's only given us there the number 1. There's only one number bigger than 9, and that's 9 itself. So that's taking ranking, and what it's doing there is it's looking at using that as a kind of a built-in function where it's looking at the positions and it's changing the positions and it's working out where they fit based on those positions. Now, what I want to do now is to take the same sort of idea of the code, but this time take the kind of positions in the list and look at the way it kind of interacts with it. So in effect, it does the same thing, but it does it in a slightly different way. So if we do ranking 2, and this time around we take in list again, and this time around we take in the item again, in just the same way that we've just done on the previous one. But now what I'm going to do is create a temporary list. And that's going to be based on the list itself. And as it's done that, I'm going to take in my position, and I'm going to set that to being 1 to begin with. And then I say, while max temporary list is not the same as the item, so while we've not reached the item, what I want it to do is to take the temporary list and I want it to remove the max of the temporary list because it's not there. And then I want it to do position plus equals 1. So it's moving that position up, and then return position. Now, I've created there a second variable. So now we've done ranking. Now if I do a print ranking and I do this one ranking 2, and we'll take the same set of numbers and we'll do it based on the number 4, and we'll make this one also based on the number 4. So we've taken the 2 based off a number 4, and I run both of those. I've misspelled position somewhere. There I have. So we'll run both of those. And it gives 4 for both. Now, both are handling those in a slightly different way in the way that they're handling the list. Now, I suspect the thing that most of you are wanting then is to be able to put these into a kind of a sorted list of sorts. So if I create then a definition which we'll call sort list in place, and we'll do that based on the list itself. And then in the thing we tell it to do list sort it. If I now in my command tell it to go actually we want the return there, so we want to take the list sorted and return the list. The problem is that with this one, it actually changes the order of the numbers in the list. So now if I go sort list in place list, so run that program, and then I tell it to print the list. Let's take this one and do a print of the list before it and then a print of the list after it, and we'll just hashtag out those two ones. So it's just doing the list before, then it's sorting it, then the list afterwards, and that's the only bit we should see run. Now if I run that, it starts off with 1, 2, 4, 6, 8, 9, 3, 4, and it ends up with 1, 2, 3, 4, 4, 6, 8, 9. Now the downside to that is it's actually changed the original list. The original list has now gone. All we've got now is the sorted list. So I want to show you that rather than changing the original list, a bit like what we did with looking for the positions and the numbers that were above it, I want to take that same idea with the list, but do it where it doesn't change the original list. So on this one, you would create we've got our definition sorting list. So let's do a definition sort list copy. And we'll take in list to do that. And then we'll say return return sorted list. So then that just returns the sorted list as a whole thing. Now, if I print the list there, so we've kept that, and then I say new list equals sort list copy bracket bracket. Based on list, of course. Yeah, so that we've created a variable which we'll call new list, which is that, and then we take out that command, so we don't run the old program that actually changes the list. But then what we do is we print the list and we print the new list. So now we've kept both versions. Now, when I run that, you'll see it ran with the original list, which is that bit. It then ran and showed me I've still got the original list, still stored as list, print list is still doing that, but print new list is running that bit, which is creating a sorted version of the new list. So you've got these versions where you either change the original variable and sort it, or sometimes you just want it sorted to know what the ranking would be, but you want to keep the original. Let's put that skill to practice, and I'm going to give you a task now that I want you to try and work through. So here are some questions that will apply that idea. So the first one is, can you take that miles to kilometers example that we did earlier on, and can you make it work for 3 different routines where you give the user a choice? Do they want to swap miles to kilometers, Celsius to Fahrenheit, or kilos to pounds? And there you'll need to build a main menu. You'll need to write some programs that'll do those various conversions in separate definitions, and you'll need to activate those based on the main menu. The next one, could you do something that takes a set of random numbers, random scores, and it creates a set of random numbers between 1 and 100, and then it ranks them to put them in order. So it ranks the numbers to put them in order. And then last of all, can you make a banner system where you can take any sort of set of words and it'll put them into a banner with asterisks on that make them into a fancy looking banner. Let's go through and answer then to the first of those Python challenges that I'd set, which was challenge 2. So again, just like before, we'll do a definition section and we'll do a main program section so that we're clear on where our split is. Now, the first definition I'm going to do is miles to kilometers. I was just debating how I was going to do that then. And we're obviously going to take in the miles variable. And when we do that, what we want it to do is kilometers equals miles times by 1.6. Let's be precise, 0.934. Yeah, slightly more precise than we were before. And now then what we want to do is we want to return kilometers. So that sends kilometers back into the program. And then we do a second definition and we call this one Celsius to Fahrenheit. Celsius to Fahrenheit. And we're bringing into that Celsius. And in terms of the calculation there, we want to do Fahrenheit, and I'm not going to spell Fahrenheit in full, but Fahrenheit equals Celsius times by 9 divided by 5 plus 32. You can see it's complicated, is Fahrenheit. And there we want to return Fahrenheit. And then my third definition, we're going to do a definition where we'll say kilo to pound, and then we'll take in a kilogram measure. And then what we're doing is we're doing pounds equals kilograms times by 2.20. I think it's 462, something like that. And then that's obviously going to return pounds. So that gives us a kind of a definition that's going to return each of those sets of things. Now, let's do the main menu. So, main menu. There's nothing going in. We're going to go print asterisk times 20. Says we put in asterisk, asterisk, asterisk all the way across. And then print main menu. And then print asterisk times by 20. Easy enough. And then we want to do print 1 convert miles to kilometers. And then print second one Celsius to Fahrenheit. I think I spelled Fahrenheit right there. I was dodging it earlier on. I was just adding the word convert because I thought it looked a bit ugly without it. And then print the third one, convert kilograms to pounds. So it's got that set of things, print for being exit. Cancel that. For being exit. Now at that stage we've got those, and now we want to build in a kind of an input. So we'll call that choice equals input which option do you want? Again, I'm going to go lazy on this with no validation around this, and you might want to watch some of the later videos on validation if you're using this code in your project, but I've added choice as just being an integer input. Now, if the choice is the same as 1, i.e. they've picked the number 1, then I want to do miles equals float input, we need it to be a number, a float input, enter the distance in miles, double bracket to close it. And then we want to run miles to kilometers. We could even just go print miles to kilometers based off miles. And that will do that. Yeah, it's not pretty. We could spend time making that print a little bit nicer, but I'm not going to. I'm just giving you a quick working answer. So now on our ELIF, I could change my choice to being 2, and this time round I want to bring in Celsius, and I say enter the temperature in Celsius. And then I'm running Celsius to Fahrenheit based on Celsius. And then finally, I'm going to run, if the choice is 3, you can see I've just copied each time round the previous bit of code. I'm going to copy in pounds, float input, enter the weight in pounds, and then this time round it's going to print kilo. I actually put a 2 in there as a word, whereas I didn't realise I'd done that. £2, and then we're going to do that based off kg. Let's make that kg as well, just so it's perfectly matching. Yeah, so kilo to pound based off kg. And so that's given us each of those kind of options as we're running through. And then we'll do else, and we'll say print goodbye. Now all that's then running inside that main menu, and then what I want to do now is very simply just run that main menu command. Now when I run that through, you should see a working solution to those 4. So it says, what do I want to do? And I choose miles to kilometers. It says, what's my distance in miles? 23, it gives me an answer. If I run it again, and this time round I go, let's do 2, which is temperature in Celsius, and I go 32, it tells me that's 89.6. If I run it again, and I choose the third one, which is kilometers to pounds, and I run that and I put in 34, it works that one out as well. And finally, if I run it and I choose option 4, it just simply says goodbye. Thanks for this session. Hope you've enjoyed it. Remember, if these sessions are proving useful, make sure you subscribe to the channel. It helps us both to keep in touch.